These are the practice problems for lesson 9. So this is problem number 1. You're supposed to draw two parallel lines. So lines that have points A and B, and another line that has points C and D. And you're supposed to choose point E anywhere that you want. It's going to be the center of rotation. So both lines are going to rotate 90 degrees clockwise around E. So if you look, AB is going to rotate 90 degrees. So if I draw a line from the center of rotation to A 90-degree rotation is going to go to here. So A is going to be about right there. And B, a 90-degree rotation is going to be about right there. It's going to be on the same line. So let's see how that works. So there you go. And you can see the 90 degrees. So A, 90 degrees to A prime. B, 90 degrees to B prime. So it rotates around the center of rotation 90 degrees. And the second line that has points C and D likewise rotates in a similar way. C rotates to C prime and D rotates to D prime. So both pair of lines rotate around the center of rotation and they basically stay together. And they're in the same relative position, just 90 degrees rotated. So CD is closer to E and AB is a little bit farther away in both cases. In this problem, you're supposed to find the measure of each of these angles. Well, what do you know about when you have two intersecting lines? It's going to form vertical angles. So if you just look, see this big angle here, this is the same size as this big angle on the other side. Those are called vertical angles. And this angle here is the same size as this angle. And the way that you finish it out is you realize or you remember that these form supplementary angles. So angle B plus this 50 degrees here, that forms a straight line and 180 degree angle. So you add them together, so 130 plus 50 equals 180 degrees. So B has to have a measure of 130 degrees. This angle also has to have a measure of 130 degrees. It is a vertical angle. So you go through the intersection on the other side, and the last angle, this angle over here, you can get either as a vertical angle, so it's 50 degrees, or you can think of it as a supplementary angle to 130 degrees, also 50 degrees. So this last angle is 50 degrees. 130 plus 50 equals 180 degrees. The next problem says find a point R so that a 180 degree rotation with a center R sends P to Q. So 180 degree rotation. In order for Q to end up on the same line as P, the center of rotation has to be on that line. And so the center of rotation is going to be an equal distance between P and Q. It's going to be the midpoint between P and Q. So you can use docere, just draw a line to this line. It will snap to the midpoint. And so this places the midpoint. R is right here. So let's use docere to find the midpoint. Only one point will work. Only R placed in this spot right here will work as the center of rotation. All right, problem number 4. It says the center of rotation is D. In the picture triangle A prime, B prime, C prime. This triangle is rotated from this triangle. This is the center of rotation. And it's going to ask you what are some of the sizes of this length or the size of these angles in its corresponding parts on the other triangle. Well, first of all, how do you find the center of rotation? You connect the corresponding points. So A connects to A prime, and then you draw a perpendicular line. This is not quite perpendicular yet. Move it over a little bit. So a 90 degree angle from the midpoint, and it should intersect the center of rotation, which it does. Do that again. Connect B to B prime. This is the midpoint right here. So a 90 degree angle, a perpendicular line from the midpoint, and it should intersect with point D, and it does. and one last time, C to C prime, a perpendicular line from the midpoint, and it intersects with the center of rotation point D. Each of these midpoints I found using Doceri. You just take a line in Doceri and put it close to the line that you want to find the midpoint, and it will snap. Eventually you get close enough, it snaps to the midpoint. Alright, so I drew some circles so you could see the rotations. So I'm going to show you the rotations as it goes around. And so notice that, go back in just a moment, this B prime here rotated from this angle B over here. And so this angle B has to be 52 degrees. It is the same. It is that 52 degrees. These are congruent figures because they go through this rigid transformation, which is called a rotation. So go back just a little bit. This angle right here, B, goes around. If you just follow it, it's right here still, right here, and it's going to end up right there. And likewise, this angle at point C is going to end up at this angle C prime. So this angle has to be 50 degrees. Again, there are corresponding angles in transformed images, so they have to be, those angles have to be equal. Finally, this side right here, BC, becomes B prime C prime, and you can see that this 4 units rotates around and lands right here. Now I filled in the angles, 50 degrees, 52 degrees. So this is 52 degrees. This is the corresponding angle. This is the 50 degrees corresponding angle, and this angle up here also is a corresponding angle. See, it doesn't look like you have to find that. And then this 4 unit segment, BC, rotates around and it lands right here. So it also has to be 4 units. And the third angle, these 3 angles have to add to 180 degrees. So that third angle is 78 degrees. I don't think it asks you to find that angle. I don't think so. Alright, so that third angle is 78 degrees. Alright. Angle BC, measure B. Side BC, angle B, and angle C. Side BC, angle B, and angle C. But anyway, you can figure out what's at angle A anyway, because it has to add once again to 180 degrees. All right, the last problem. Point is -4, 1. They're telling you that it's rotated 180 degrees counterclockwise. So going this way, the opposite way of a clock, and it's going to end up over here using the center of rotation as 0, 0. So you know that it's going to go through, the line is going to go through the point that you're starting at. It's going to go through the center of rotation. Since it is a 180 degree rotation, it's going to be on that same line. And it's going to be an equal distance on the other side. So if you count 4 units this way and 1 unit up, so this is -4, +1, then to get over here, the order of the coordinates stays the same. So instead of -4, it's going to be +4. And instead of a +1, it's going to be -1. So the order of the unit stays the same, or the coordinates stay the same, but the sign for both of them changes to the opposite sign. So you end up here at 4, -1. Now it gives you some possibilities, some other points. -1, -4, which is answer A. That forms a 90 degree angle. So notice that the coordinates are reversed and one of them changes signs. So it's going to be -1, -4. So you have to end up down here, so both coordinates have to be negative. So if you're starting here, -1, +4, then they both have to be negative. So it's going to be -4, -1, but they also switch order. So it's going to be -1, -4. So that gets you to this 90 degree angle right here. -1, +4 is up here. There really is, other than just the units, At this time, there's not really much of a relationship there. And 4, 1 is a reflection. So it's like going up 1 unit in both cases, but taking a turn in the opposite direction. So negative 4, 1 is reflected over the y-axis, and it lands over here. So since the y coordinate's the same, they're using the y-axis as the line of reflection, and so it's going from negative 4 to positive 4. It's as if you're traveling down a road or up a road, and instead of taking a left turn, you instead take a right turn, and you end up at 4, 1. Those are the problem sets for the practice problems for lesson 9.